Hello DC candidate, welcome back to School for All. So if you are discovering this channel through this video, Mr. Chube Fanche Cabral, you are physics teacher in School for All. So I discovered that many of you people don't really master graph questions under paper 1. You don't really master graph questions under paper 1. Why you people know that at least 5 questions on graph questions will come in paper 1. That is already 5 on 50. Yeah, it means that if you master your graphs section of paper 1, there is already 5 on 50, and we all know that what paper 1 is already 30%. So 30% of those 5 on 50 is already 3 all over 100. That 3 all over 100 can already change your grades. Yeah, so be careful. Don't neglect anything at the level of the exam. So today I decided to do a section under paper 1 which is mainly focused on graphs. So I will really show you how to answer that type of questions so that all your doubts should be clear, students. So let us start our lesson of today. Okay, now as usual, I'll first of all do a small recall on the type of graph that we have. I'll first of all do a small recall on the types of graph that we mainly have in paper 1. So types of graphs. So we'll start with what we call straight line graphs. Straight line graph. Straight line graphs. Okay. You all know that what? We all know that a straight line graph is a line, can be what? Can be an increasing straight line graph or a decreasing straight line graph depending on the gradient. So if the gradient is positive or the gradient is negative. So let us start with this one. So let us start with a graph with the equation in the form y equals to mx is okay. Then we'll go with y equals to mx plus c. Now, the graph of this type of equations is simply what? M is positive. It means that we should have, if this is y, this is x, it means that we should have a positive gradient because M here represents the gradient. You all know that. This represents the gradient. Is okay. And the graph, in fact, the equation is not having y-intercept. It means that the graph will start from the origin and go up. That is it. So it should be an increasing straight line graph to make sure that the gradient is positive and the intercept is starting at what? At the origin. Now, for this one, it's slightly similar but different because we are starting at a value which is called what? The y-intercept. When x takes the value 0, y will take the value c, making the graph to start here. So I think that is already the difference between the two graphs. Here we are having the y-intercept, where we are not having. Now, let us now go to equation with negative what? Negative gradient. It means that if I'm having an equation y equals to negative mx plus c, you see that here we are having a negative gradient. And for us to have a negative gradient, we should have a decreasing straight line graph. Something like this. If this is our C, we'll have something like this. As easy as that. So with this type of decreasing graph, we are sure that the gradient will be negative, indicated by what? By the form of the equation. So these are the different type of straight line graph that you people can have. And the last one that you people can also have is what we call constant graphs, like this. And this constant graph is described by when y maybe is equal to a constant a, where a is a constant. Is okay. You can still have another one like this, x, y, but here now is s equals to a. So you can have a horizontal graph and a vertical graph. When y equals to a is a horizontal graph, vertical graph. So these are the different straight line graphs that you people can see in the paper 1 coming. Now, let us continue with another type Let's talk about curves. Let us continue with another type. Okay. Now let us talk about curves graph. Curves graphs. Under curve graphs, you see that what here now we are not having straight line graphs, we are having curves. It means that it is forming a curve. So we can have an equation in the form y equals to ax squared. You see that what here this represents a curve. Here this represents a curve like this, y and x. Look at how is a is positive. It means that the curve should have what? A minimum turning point. So the curve should go like this. Is it okay? If I was considering negative, because in physics we mainly consider what? The positive section of the axis. If I consider negative, I will start like this, like that. Is it okay? Since I'm not considering this one, so this is how the curve will look like. I hope we are together. Now, if I now take like y equals to ax squared maybe plus c, you see that the curve will not now start at the origin. We start maybe at somewhere here and go like that. Is okay? This is x, this is y. Okay. Now, this happens when the coefficient of a is positive. Now, what happens when it is negative? You see that y equals to negative ax squared. You see that the curve here will be simply equals to now we'll form what? Maximum turning point. Something like that. Is okay? Maximum turning point. Okay. Now we can still have a curve. We can still have curve in the form of exponential decay curve or charging curve. Is okay? We can still have curve in form of exponential. We can still have also curve in the form. So let me put other forms of curves that we can have. This is what we call exponential. So let me put it in the form of exponential. In the form of exponential. So we can have maybe y equals to 2 to the power x. That is the form of exponential. We can have y equals to exponential. Y equals to maybe y0 exponential of a negative lambda t. What we know that this one is a decay curve. We can have y equals to y0 into 1 minus e to the negative lambda t. This one is a charging curve. For all those different forms, the curve, we can also have y equals to 1 over x. Is okay? All these will give us what? Curves. Are we together? All these will give us curves. Okay, so here and you see that the curve for the exponential curve is slightly different because you see if I have y here, if I have x here, if I want to draw the curve maybe for the decay, this one, you see that the curve will start somewhere but we never touch what? The x-axis. So this for y equals to y0 exponential of negative lambda t. And for this one, for a charging process, you see that it will go somewhere like that. This is y equals to y0 in bracket 1 minus exponential of lambda t. So that is it. It's okay. Starting here at 0 is going like that at infinity. So that are the different types of curve that we can also have. Now, let me take a small NB here. Let me take a small NB. It can happen that rather than having y equals to maybe ax squared, you are either having maybe x equals to what? Or you're either having y squared maybe equals to ax. How do we sketch this type of graph? Now, when to sketch this type of graph, you go directly. If this is your y, this is your x, is okay? If this is your y, this is your x, it means that now I will not follow the curve, will not follow the y-axis. No, the curve will rather follow the x-axis. The x-axis is okay. It means that for a small change in x, for a small change in y, there is a bigger change in x. So it means that the curve will follow what? The x-axis. How you understand it? Because when I'm having a y equals to ax squared, the curve follow what? Who? The y-axis. But when the y is square, Now the curve will follow who? The x-axis. So you see this small difference. Yeah. With our example, okay, the first here is proposing us here. Let me first of all read the instructions. This is section 3, 5 questions. So the question is going from 46 to 50. So we are saying each of the questions from 46 to 50 has 4 sets of graphs A to D. Which of the graphs in each question best fits the relationship between x and y? Is okay. Now let us read the first question. The first question is average kinetic energy. So y represent the average kinetic energy of the molecules of a substance undergoing what? Change of state, and yx represent temperature of the substance. So yes, student, there is not like a direct relationship or a direct question that can show us the relationship between x and y here. No. Here is your definition or the theory that you know under the concept. Is okay. We all know that what? We all know that during change of state, the temperature of the substance remains constant. Why? This is because the energy given to the substance, here is not needed to raise the temperature of the substance. No, it is needed to change the state of the substance. And change of state means that what the kinetic energy of the molecules have increased. Are we together? Yeah, if I'm changing from liquid to solid, maybe if I'm changing from liquid to gas, it means that the kinetic energy of the substance will increase. They are more mobile. Is okay. So from there, we can directly deduce that what? I will look for a graph where temperature remains constant. I will look for a graph when temperature remains constant, that is x remains constant, but y increases because the energy given to the substance is there to increase the kinetic energy. So kinetic energy increases, y temperature remains constant. So the best graph there will be D, that represents this. So that is the best graph. I will not take the other one like this. No, it's not kinetic energy which is constant, but temperature. As easy as that, you have your mark. Without wasting time, let us go to 47. So 47 of the past question is saying y represent the mean square speed of the gas molecule, while x represent the absolute temperature of the gas. Okay, students, it means that the only way for us to have an idea on how the graph will look like, we should go and look for the equation relating what? The mean square speed of the gas and the what? And the absolute temperature. Okay, now in paper 1, as I always say, your formula booklet should be your holy Bible. Yeah, because from there you can have all the formulas that I know that you don't master. Other can master it, that is good. Now, so I know that from my formula booklet, the kinetic energy of the molecules is 3/2 kT. Now, but they are talking about the mean square speed. The mean square speed is inside kinetic energy, but another kinetic energy of the molecule is half mc bar square, mean square speed. From there, we see that what? The mean square speed is equals to so that is it. So the mean square speed is proportional to t. So this one is what? It's a direct proportion. It's okay. So it's exactly as the equation y equals to mx. And I all know that what? The equation y equals to mx should have a graph going like this. It's a straight line graph starting from the origin. So from there, making our best answer to be A. As easy as that. How you understand it? It means that this variable, which is the mean square speed, is proportional to t. It's a direct proportion. And we all know that what the graph for the proportion is y equals to mx, and it's a straight line passing through the origin. Okay, students, so let us proceed with 48. Let us proceed with 48. Okay, 48 now is 48. So the resistance of a thermistor with a negative temperature coefficient of resistance and temperature. Okay. First of all, we all know that what a thermistor is not is a non-ohmic conductor. Are we together? It means that it does not obey Ohm's law. It means that his VI characteristic is a curve. That is what you should know first of all. Now, another thing, they mention negative temperature coefficient. Negative temperature coefficient. So negative temperature coefficient means that what? Means that as temperature increases, how does the resistance vary? The resistance of the material reduces. It means that the material now can better conduct when temperature increases. The conductivity increases. So you can also see that T and V are not proportional. As T increases, R should reduce. They are not proportional. They are inversely proportional. Okay, but it's an inverse proportion. It means that T varies inversely as R. Are we together? So the best graph that can represent the resistance and the temperature, so I think it should be R inversely proportional to T. It should be a curve that is decreasing. Are we together? It should be a curve that is decreasing. And the curve that should decrease there, the best curve there should be this one. Yeah, I think the best curve should be this one, making the correct proportion to be C. That is it. Making the correct proportion to be C. I cannot take A, I cannot take B, because A is a straight line, it's not a curve. B is an increasing curve, that is wrong. C, yeah, it is a decreasing curve. But D is a decay curve. Here, there is not exponential here, so we cannot take D. D is a decay curve. So the best curve there that can describe this relationship is C. Okay, now let us move to the next question. Question 49. Current in an inductive coil when switched off and the time. Current in the inductive coil when switched off and the time. Okay, we all know that what an inductive coil can store energy. So it will store energy when we switch now. When we switch now the current off, there's a little energy that will come from the inductive, but it will decrease with time, and that energy and that current will decrease as a decay curve. Is okay. So that current will decrease as a decay curve. So that is it. So this is how the current will decrease when we cut off the current in the circuit. Is okay. So the current delivered by the inductive coil will follow this equation. It means that the best graph that fits this equation will be D, decay graph. Okay. Now let us go to 50. Y represents here the total energy for a body in a simple harmonic motion, and S is the time. That is easy. And the time you're talking about total energy is okay. It means that it can never change. The total energy will remain constant throughout the motion of the body. And the only graph that can represent it, a constant graph, it should be a constant graph where Y represents the total energy and X represent who? The time taken. So who is constant? It is Y. Therefore, I should have something like that, making the best graph to be C. Anytime we talk about total mechanical energy or we talk about mechanical energy, you should know that it's a constant graph because it does not vary. It's always constant when the system is closed or in a vacuum. Okay, so let us move now to the next year. Okay, the next year is still question 46. Yeah, always. Now, you're saying the displacement of a body undergoing simple harmonic motion and the acceleration. Displacement of a body undergoing simple harmonic motion and the acceleration. Okay, so here I should first of all come out with the equation relating the two variables. I know that what the acceleration of a body undergoing simple harmonic motion is negative omega square. What? Y. Are we together? So this is like the equation of a straight line with a negative what? Equation of a straight line with a negative gradient. Is okay. And we all know that our equation of a straight line with a negative gradient should be a decreasing straight line. Here we are having all the section of the axis. This is Y, this is X. So we all know that first of all it's passing through the origin because when X takes the value 0, Y takes the value 0. But we are having it can pass like this, or it can pass like this. Those are the two lines that can pass through the origin. Now, which one should we choose? Which one should we choose between the two? To know which one you should choose, you can consider negative means it should be what? A decreasing graph, so that the gradient should be what? Negative. This is a decreasing graph. The gradient here will be negative, but this one is an increasing graph. The gradient will be positive. Or another way to do it, you should maybe replace x by 1. You see that y is equal to negative 1. So if x takes the value 1, you see that y will take the value negative 1. 1, negative 1. Are you see? So this point is what? Is along who? Along the graph, along this graph. So it is a point of this graph, therefore this graph should be the correct graph. Therefore this one should be the graph y equals to x, and this one should be the y equals to negative x. And from that, the best proposal from that way will be B. As simple as that. Now, let us continue. Let us continue with question 47. Now, question 47. Y here represents the velocity of a train that takes off from rest at one station and accelerates uniformly before stopping at the next station. And x now represents the time. Simple as that. I know that what? What is the relationship relating velocity and time? It is v equals to u plus a plus at. Are we together? But we are starting what? We are starting from rest. It means that this one is 0. I will have v equals to a. At, this is an equation in the form y equals to what? Mx, where x represents t and v. Therefore, that should be what? A straight line graph starting from the origin. So at the beginning of my motion, I should have a straight line graph starting from the origin, represented by this equation. Now, after, because here a is positive, don't remember a is positive because it is from rest and one move from another station, moving with what? A uniform, in fact, and accelerate uniformly means that a is positive. Now, after accelerating uniformly, then he now stopped at the next station. For him to stop, it means that he should decelerate. So for the other part of my motion, v should be equal to negative a. At, it should decelerate. So this should be the equation in the form y equals to negative mx, a decreasing straight line graph. Therefore, I should decelerate to 0. This one is y equals to negative mx. This one is y equals to mx. Showing that what? Here it is accelerating, represented by this. Here it is decelerating, represented by this, making the best answer to be D. As simple as that. Now, without wasting time, let us move to the next. It is y represent the voltage. Y represent the voltage across a diode, and x the current through the diode. Now here there is not an equation that you can use that can describe the curve. No, it is the knowledge behind what is a diode. Is okay. So if you are having a diode, we all know that what? A diode is having what we call a barrier PD. It means that if the voltage across the diode is less than a certain value, no current flows through the circuit. Let's take maybe that barrier PD maybe to be 0.6 volts. So this is Y, this is X. It means that for any value less than, for any voltage less than 0.6, no current flows. But above, a certain current now can flow. A huge amount of current can flow through the circuit, making now from here to have what? A curve, an increasing curve, because the amount of current will increase as the voltages across the diode also increases until at a certain amount it becomes constant. So making the best answer to be A. Now let us go to 49. Let us go to 49. We are talking about the square of the velocity of a satellite orbiting the Earth, and x is the radius of the orbit of the satellite. So first of all, come out with the equation relating the two. Square of the velocity orbiting the Earth and the radius of the satellite. So if you don't know the formula, then you can derive it. For any object orbiting the Earth, should have what? Should have 8 centripetal force balancing what? The gravitational force is okay, the gravitational pull of the Earth on him. So I will know that the mass of that satellite, m square all over the radius should be equal to g m all over the radius square. So cancel one time here, one time. So that v square is simply equal to gm all over r. Now they're asking the square of the velocity of the satellite orbiting the Earth. It means that v square here is proportional to 1 on r. It's like we're having y proportional to 1 on x. We should already have what? A curve. This represents a curve. But the curve is what? It's a decreasing curve. Are we together? So this is a decreasing curve. So we should look for the proposal. Making, as I'm seeing here, b is already wrong. D is already wrong. Even y is wrong. Why am I saying that y is wrong? Y is wrong because okay, as I'm saying, y is wrong because y is showing us that when x takes the value 0 is okay, y is set is somewhere here, which is wrong. When x takes the value 0, y is not existing. It means that we cannot have, it's impossible for us to have what? The y intercept. From that analogy, we can directly deduce that the best graph here should be A. The best graph here should be A, because A is showing that we are not having a y-intercept and we are not having the x-intercept. Very correct, because look at, we cannot have an x-intercept. Xy may be equals to 1. None of them should be 0. We cannot have x and y intercept, making the best graph to be A. As simple as that. So you people should reason. Small reflection, you have your mark. Now let us go to the last part of our question, which is question 50. Y here represents the mass of a rocket moving with a constant linear momentum, and S represents the velocity of the rocket. Okay, mass of the rocket moving with constant linear momentum, and S represents the velocity of the rocket. We all know that what? A rocket, the mass never changes. Are we together? The mass never changes. It never changes. It means that when you are already seeing that mass of something, mass is constant. It's not weight, it's constant. Yeah, it's okay. It is a measure of all what? The quantity of a body, all the, let's say what? It's okay, it's constant. So it does not depend on where the rocket is or the velocity, how they know. It means that my y-axis should be constant and the x should vary because the velocity of the rocket can vary. That is not my problem. So I will look for where y is constant, and where y is constant is A, making A my correct answer. Don't even start like thinking, oh, which relationship relates velocity with mass. No, mass is constant, therefore you look for the axis that represent the constant value. Okay, students, so let us now move to the next year. 46. Okay, for this year, Y represents here the average kinetic energy of a molecule of a substance undergoing a change of state, and F represents the temperature. We did this already. So from there, we can already see the answer. The answer will be where the y-axis is constant and the x-axis is varying. So making the best answer to be, it's temperature that is constant here. So where the s is constant and the y varying, making the best answer to be D. As simple as that. Then, okay, 47 is the maximum kinetic energy of a photoelectron, and X is the frequency of the incident radiation. Here, there's no way for you to come up with a graph without knowing what? Without knowing the equation relating the maximum kinetic energy and the frequency of the incident radiation. Okay, we all know that one for Einstein photoelectric explanation or equation. We all know that what the energy is okay. The energy of a photon is equals to the energy needed to move the photon from the metal surface, which is the work function, plus the kinetic energy that the photons uses to go away from the metal. Okay, and I all know that what key E max will be simply equals to E minus W0, and E is what? E is HF minus W0. You see that already the relationship between kinetic energy maximum and frequency, this is it. It looks like the equation y equals to what? Y equals to mx plus, minus c. And we all know that the equation represented by this form should not pass through the origin because we are having a negative y intercept. Is okay? It should not pass through it should be a straight line with a negative y intercept. So let's say this is c here. It should be something like that. Are we together? Because when s takes the value 0, y should be negative. It should be something like this. A straight line passing through, which is not passing through the origin. Okay, so from this, our graph, let us now see which proposal fits best our solution. Okay, from there, I can see that C, look at, because they did not consider the negative part of y, so I will wipe here like this. Why wiping here like this? You see that I will start here, making the best curve there to be C, as simple as that. Now, after doing that, let us now move to 48. Okay, now 48, we are having the potential energy of a planet so 48, y represents the potential energy of a planet orbiting the sun, while s represents the distance from the sun. Okay. Here you should come out rapidly with the equation relating potential energy and the distance. Is okay? We all know that what potential energy, gravitational potential energy, is equal to mv, where v is the potential. So mg m all over r. So it means that this is the equation of the form y is okay. So y is indirectly proportional to r. So that should be what? That should be simply a curve. So we will look for the graph. We look for the graph that is having a curve. Okay, I'm seeing A is already wrong, B is wrong. C is correct because it should be a decreasing. It should be a decreasing curve. It should be a decreasing curve, making C to be the correct answer. D is an increasing curve. It's wrong because the relationship is indirect. Then let us go to 49. So 49. The magnitude of the velocity of a box falling through air from an aeroplane in the sky and the time of fall. Simple as that. Magnitude of the velocity falling through air is the equation v equals to u plus 80. Let's say initially is 0, v is simply equals to a 80, v is proportional to t. This is the equation of mx. As simple as that. So the best way for us, this is an equation which is starting from the origin. It's a straight line equation, making the best proposal to be A. As easy as that. Okay, now 50. 50. 50. Okay, we are having the reactance of a capacitor and the frequency. Reactance of a capacitor, I don't know if you put it RSC secret. It's very easy. Reactance of a capacitor C is given as 1 over omega C, which is 1 over 2 pi Fc. We can see that Fc is inversely proportional to what? Frequency. So I should have a decreasing curve. And the only graph there representing a decreasing curve is C. As simple as that. So if you have the relationship between the reactance of the capacitor and frequency, from there you have your graph. Okay, so then now let us move to the last year that I want us to answer. So for this year, let us start with the first question under graphs. Y here represents the distance traveled by a cyclist that accelerates down a hill, then runs at a steady speed before ascending the next hill, then time. Now, here you should first of all divide the different parts of your motion. Very important. The distance traveled, I know that what? The formula is ut plus half 80 square. Are we together? Now, the distance traveled by a cyclist that accelerates down the hill. Let us say the initial velocity is 0. It means that when it is accelerating down the hill, the first equation relating his motion, it is s equals to what? S equals to half a t square. Accelerating means that a is positive. So this is like the equation in the form y equals to what? Mx square. Are we together? And A is positive means that we should have what? It is a curve with a minimum what? It is a curve with a minimum turning point. So it should be a curve going like this, passing through the origin. Should be a curve going like this. That's for the first part of our motion. We are already having what? A curve increasing. Yeah, going like this. Because it should be like this. But I don't want to draw this part. Starting from the origin. Positive means minimum turning. Now, for the next part of the equation, we now say that then runs at a steady speed. Steady speed means acceleration is 0. It means that S should be simply equals to what? Ut. This part is 0. It runs at a steady speed. That part is 0. The distance traveled will be simply equals to Ut. Are we together? Yeah. It means that here now it resembles an equation of a straight line mx with a positive gradient. Therefore, we should have something like this. Is okay? Now we are not starting at the same time because after this, after this, for the next part of the equation, we should have something like that. So I'm just from joining this first part at a certain time here. Then after is moving with a straight line. It's coming from this equation. Then the last part of the equation now, before ascending the next hill. Ascending the next hill means that it is going so that you should reach the top of the hill. At the top of the hill, this velocity will be 0. It means that it is decelerating. It's not accelerating. After moving at a steady speed at the level of the hill, he now starts ascending. It's okay. He now start ascending, and as it's ascending, when he reach the hill at the top, he will stop, showing us that what it is decelerating. It means that for the other part of the equation, exactly at this level like this, he should go like this, like a curve decelerating. So because his equation should be S equals to now, let us say its initial is 0, S equals to now negative what? Half 80 squared. So this is the equation in the form negative AX squared. It means that we should have now maximum turning point. So at this level, it should now go like this. So from that, making our best graph here to be from there, making our best graph here to be C, as simple as that. Okay. Now let us move to 47. Now 47, Y here is the repulsive force between two molecules, and S is the distance between the molecules. Okay, so what you should know here is that the repulsive force exists when the molecules are close together. Is okay? When the molecule is moving far apart, repulsive is now changing. It's reducing until it become what? Let me put it like this. This is when this here repulsive dominate because R is less than the equilibrium separation. Then at a certain level, when the distance will increase between them, R will be equal to what? Equilibrium separation. When now the distance will be far apart, you see that now R is greater than equilibrium. But here now it is attraction that dominates. Attraction dominates, repulsion dominates, equilibrium separation means that the summation of F equals to 0. It means that for us to come out with a graph, while understanding what I'm just from saying, it means that what? As the distance increases, the repulsive force reduces up to it. It is 0 when the distance between them equals to what? The equilibrium separation. I hope we are together. It means that the best graph that can fit this, what I'm just explaining, we consider what that repulsive force. The repulsive force is the inverse proportional to what? To the separation between the two molecules. And the best graph that can represent it should be, I think it should be C. Yes, that would be the best graph. Why am I saying that? Because when the molecules okay, students, so from this I can say that the best graph that can explain that should be B. This graph is okay. Yeah, it means that we should make sure that there's not what? Y-intercept is the reason why I cannot take C, because C is showing that there's Y-intercept. There cannot be Y-intercept here. It's okay. The distance between the two molecules cannot take the value 0. Because for us to have Y-intercept, we should take the R should be 0. R cannot be 0 here. It will be infinity. So there is not Y-intercept here. There is no X-intercept, making the best graph to be B. Yeah. Let's move to question 48. 48. is saying that Y here represent the number of atoms of the stable isotope of lead produced from the decay of a fixed quantity of polonium, while T is time. You people should understand. It means that if NT here represent the number, there is a formula. Yeah, NT, that is the decay curve, right? NT is decay equation. NT here represent the number of atom of polonium left. So this is the number of atoms left. N0 is the initial number of atoms. But we are looking for what? We are looking for the number of atoms of stable isotope of lead produced from the decay. So people should understand, the number of atoms of lead produced is the same as the number of atoms of polonium decay. Are we understanding? So the number of atoms of polonium that have decayed will give us the number of lead that have been produced, because polonium, I think it's polonium is decaying to produce what? Lead. It's okay. It means that the number of atoms of polonium decay will give us the number of lead. Now, how do we calculate the number of atoms of polonium decay? Will be the initial number of atom minus the number of atom left. I will have the number of atoms that have decay, making now this equation to be N0 minus N0 exponential of negative lambda T. Negative lambda T. Now, if I want to factor, I have factor N0 will be 1 minus exponential of negative lambda T. Are you seeing that the number of atom of lead produced is giving us a charging equation, like when you are doing capacitors? This is a charging equation of a capacitor. So it should be an increasing curve. It should be an increasing curve. So, and the increasing curve there should be how? Should be like this, starting from the origin. Yeah. So the number of atoms of lead produced is an increasing curve, while the number of atoms of polonium left should be what? A decreasing curve. So this is the curve for NT, but this one is the curve for N of lead, which is the same as the number of atom decayed. Okay, so making the best answer to be C. So people should really understand what they are asking for. Now let us go to question 40. So question 49. The net force between the two identical point charges moving away from each other, the distance between the charges. Easy as that. We all know what the net force between two charges, F, is equals to K Q1 Q2 all over R squared. So F is inversely proportional to R squared. So the net force between the two identical point charges moving away from each other, then the distance between the charges. So how does the net force varies? So as they are moving away from each other, R is what? R is increases, therefore F should what? Reduce from this equation, and it should be a curve. And the best curve that fits this relation will be, I think the best curve that will fit this relation will be, as I'm saying, B is wrong, D is wrong, C is also wrong because it's an increasing curve. So we are forced to take A directly without even thinking, because the others are wrong. Now 50 is the mechanical energy of a simple pendulum swimming in a vacuum chamber, and then the time. I told you that when you're talking about mechanical energy, total mechanical energy, it should be constant. It's okay. It's different from kinetic energy and potential energy. Those one can vary depending on the position of the pendulum. So here we look for where the y-axis is constant, making the correct answer to be D. As easy as that. Is it? It's okay. Now let me explain quickly. This is a small bonus. If now they were asking for the curve for kinetic energy, potential energy, and mechanical energy. So this one is not difficult. If you are having a simple pendulum, you consider three positions of the simple pendulum. because this is how the simple pendulum is swimming, like this. You consider 3 positions. Now, at the middle of, let us say it is starting here. So it means that at maximum displacement, potential energy is what? Maximum. I hope you understand why I'm saying that. Kinetic energy is 0. Therefore, mechanical energy, we all know that one. Mechanical energy is potential energy plus kinetic energy. Therefore, mechanical energy, since this one is 0, we take the value of potential energy. I hope you understand the potential energy is maximum because at maximum displacement, the ball or the body has gained height and it is what? At rest. Because for him to go there and come back, it should first of all stops. So potential energy there should be maximum because it's okay. It has gained what? Height. Then when it's medially moving and when it reaches the middle, the minimum displacement, that is the middle, you see that now here potential energy is 0 because he has lost the small height that he was having. Now it is at 0 height. Kinetic energy here is maximum because it is moving. Then making here the mechanical energy now to be simple because of the kinetic energy. Why here potential energy is still maximum? Because it has gained height. Kinetic here is 0 because it's at rest. And then the mechanical energy here will be simple because what? Potential energy. You see that mechanical energy is never 0. It's constant from potential to kinetic potential. So making our graph, if I want to draw the graph here with the axis, if this one is x, this one is negative a, you see that for kinetic energy, it is maximum where minimum displacement 0, this is a minimum here. So making the graph to pass like this. Now for potential energy, it is maximum where at the extremities. So it is maximum at the extremities here and here. So making a graph and minimum here, making a graph now to pass like this. And now you see that all through the motion, we are having a constant mechanical energy. This potential energy, this kinetic energy. So that is a summary on the energy when a body undergoes simple harmonic motion. So that will be all about our lesson today. So I hope that it really helped you. I hope that you people have your 5/5 under this section in paper 1. So I wish you good luck to all my students. We are together.